All right, in this lecture we are going to talk about common logarithms first, right? So the last time I introduced you to the idea that 2 to the y equals x is the same equation as y equals log base 2 of x, okay? And these are the same equation, this one being exponential, this one being logarithmic. Now, at this point, right, if we have the y equals log base 2 of 10, we still really don't know the answer to that because that's asking me 2 to what power equals 10. So when I'm using base 2 or base 4 or 6, there's no way that I can put this in my calculator, at least at this point. But there are some that we can, and since we live in a base 10 world, anything with a base 10 we actually can. So if we have 10 cubed equals, right, that would be 1,000. The log equation to go with this would be, normally we would write log base 10 of 1,000 equals 3. Now because 10 in our world is such a common base that when we write just log without a base, that's like implying that that is a 10, okay? So this question would mean, you know, if I wanted to, I know it's not written here, if I was given it without knowing this up ahead, then if I was just given this part, I assume, because there's no base written here and I'm just using log, that that is 10 cubed equals 1,000, okay? So when we're in base 10, we don't actually write the base because we used base 10 for so many things. So for instance, right, so I know that this is actually 3, right, because I know that I can write 1,000 as 10 cubed, but now actually I can just pop this in my calculator. So here's my log button that says log, and then I just put in 1,000, close my parentheses, and I do get out 3. So this is the first one that I can actually evaluate with my calculator. So maybe I want to know, you know, I wanted to know where this was. I don't want to use 10, but let's use a different number so that we don't know. So what if I have 10 to the x equals, I don't know, 25? What am I going to do with that? So the way that I do that is to actually put that in log form. So this would be log base 10, which I won't write, right? And then is equal to x. So my 25 goes in here. So this is actually just a number that I can put in my calculator. So I just put log 25 up, and I'm going to round to 3 decimal places. So that would be 1.398. So my x is approximately 1.398. Okay? So we always want to carry these to like at least 3 decimal places past, right? So this is 1.397, and then the 9 rounds the 7 up to an 8. So that's why I called it this. And I use the approximate symbol because it is an approximation because I did round. Okay? So, you know, let's just see, well, what would be y equals log of 127, right? Just pick a number. Well, I can figure that out because I'm in log base 10. I just put it in, and it is 2.10, and the 8 tells me I should round up to a 4. So this would be y equals 2.104. Okay? Approximately. I should use my approximation. Okay? So, you know, base 10 is actually used a lot for earthquakes. So, like for instance, if the amount of energy released from an earthquake was 300 times greater than the amount of energy released from another, then the equation 300 equals 10 to the x is basically going to tell us the difference in magnitude on the Richter scale to the nearest thousandth. So we can say, okay, so again, I have 10 to the x equals 300. I know I can fall back onto my log form. So that would mean that x is equal to log, I won't write base 10, of 300. I put that in. Whoops, not just 300. I got to put the log first. 300, close my parentheses, and I get 2.477. Okay, so that was the difference in the magnitudes. Okay. Alright, so another one that we can use a lot. Now again, we still can't at this point put in log base 2 of something, but we can put in log base 2 of, or 10 of something, because we have a calculator for that. You might also notice that right above my, or below my log key, is this ln key. So that is a new one. We've talked about e before, but we haven't really talked about it in logarithmic terms. So if I have y equals e to the x, then it also has an inverse, which is I start out with x equals e to the y, and so my log equation would be y equals, I'm going to write it like this first, log base e of x. Now log base e, so we use log, right? If I just use log base x, then this is implied it's base 10. Now if I use, this is a new one, the natural log we call it, I'm going to write that, natural log, this is base e, and we use ln. So basically this would be ln x. So when I use ln, I'm assuming I have its base e down here. So this would be e to the y equals x, right, which is this. So this is also one that we can put in our calculator because we do have an ln button. So these ones that we use all the time, like tens, we use that in lots of things on daily life, and then the natural log also pops up a lot in science as well. So we tend to use the natural log a lot. So for instance, now these look a little bit different, but in ln, right? So if we wanted to know what e to what power gave us 3, then we could say, okay, well in logarithmic form this would be ln, because that's base e, of 3 equals x, right? It's always equal to my exponent. So that means this time I just use my ln button down here, ln of 3. And that gives me, oops, I put in an extra thing. Hit enter, and that is 1.098. So I'll say 1.099. So x is approximately 1.099. Okay? So if I just wanted the natural log, right, if I wanted to know the natural log of 600, right? Again, all I have to do, it's just a value. I put in my calculator, I put in the natural log of 600, and that is approximately 6.397, because there's a 9 after the 6, so I'm going to round that up. So the natural log of 600 is just approximately this. So this is a little different, but again, so if I just write y equals log base 10, right, this is implied, this is base 10 without writing it, and if I write ln of x equals y, then I'm assumed I'm in base e. Okay, so those are the most two commons, and those are the ones that we like because we have the button on our calculator. Alright, so we'll talk about graphing and graphs of them next.